Okay, yesterday we went through a question like each of these. Okay, and when we did that, I said to you, this question is exactly the kind of thing that will appear on a unit exam. So this quiz is probably one you'll want to watch one other time before the unit exam, okay? Because they are posted in PowerSchool along with your quiz. If you click on a quiz in PowerSchool, two links come up. One says quiz 4 questions, the other says podcast of quiz 4, or in this case, quiz 8A, okay? So if you click on that, you can try it again, watch the solution. But this is exactly what I will ask, okay, on the unit exam in terms of these two things. All right, so for question number 1, okay, we have a boat that can travel at 1.1 meters per second on still water. And it heads directly south across a river that is 25 meters wide. Okay, so I know this river is 25 meters wide, okay, and I know that it is traveling south at 1.1 meters per second. Okay, I also know that the river current is 2.3 meters per second east. So my triangle will look like that, and I'm looking for, first off, the resultant velocity of the boat, which is represented by this red arrow. Okay? This is the resultant velocity of the boat, and this would be the resultant velocity's vector, which I also need because velocity is a vector quantity. All right? 1 mark if they have the diagram drawn. Okay. So in order to calculate V, the first thing I need to do is Pythagorean theorem. So that'll be 1.1 squared plus 2.3 squared. All right, so we're looking at 2.550, okay, for that. Meters per second, 1 mark for that. Okay, and then we got to find theta. Okay, theta will be tan to the minus 1 of the opposite side, 2.3, divided by the adjacent side, 1.1. If you drew the triangle the other way, as long as you have the right direction on it, you'll be all right. So we'll have second tan, 2.3, whoop, not 23, 2.3 divided by 1.1. All right, so I'm getting 64.4 degrees. Okay, and for me, that is east of south. All right. All right, so that means then that our final answer is going to be 2.6. Sorry, not 2.6. It was 2.49, wasn't it? Yeah. Okay, so 2.5 meters per second at 64 degrees east of south, or at 26 degrees south of east. Either one of those directions is acceptable. Okay. Sorry, we'll get a mark for this. We'll say that first part's out of 4. Okay, I'm just going to change that to be out of 4. Okay, questions on part A? All right. Their direction must match, guys. If they don't have the right direction with the right angle, it's not right. They must have the right number of significant figures. Okay, for part B, we want to figure out how far downstream does the boat end up. All right, so we have to do a couple of calculations. First off, I know that I'm going downstream, which is the direction they're asking about, at 2.3 meters per second. If I can figure out how long the boat's in the water, I can figure out how far I go, because V times T will give me D, right? The problem is I don't have the time right now. But I can find it because I know how far it is across the river, and I know how fast I'm going across the river. So I can find those things out right now. Okay? The time to go across will be D over V. That'll be 25 divided by 1.1. I think that comes out to 23 seconds or something like that. But we'll get all the decimals here. All right, so yeah, 22.73 seconds. Okay, so we'll give them a mark for that. Okay, now that I know how long I'm going across the river, I also know how long I'm going down the river. So I can figure out how far down the river I end up. D equals V times T, which will be 22.73 with all the decimals in it, okay, times the speed I'm going down the river at, 2.3 meters per second. And so we'll give them a mark for that step there. All right, so they're going to end up, we only have two significant figures here, they're going to end up 52 meters. I'll accept east or downstream. Okay, so that'll be the third mark for our feet. Okay. Questions on that one? Okay, question number 2, vector addition question. One of the vectors is straight along a compass direction, and the other is angled. So our diagram is going to look something like this. We go 12 meters due north, and then we go 16 meters at 30 degrees south of west. So here's west. I'm going to go 30 degrees south of that. Okay, it's not really to scale, but now it is. Okay, so this is 16 meters. This is 30 degrees, probably not exactly 30 degrees. And our resultant then will look like this. Okay, they can have a mark for the diagram. Okay, now we got to find all the x's and all the y's. Well, for the 12 meter vector, that's easy. The x component of that is 0 meters because it's due north. The y component of that is 12 meters north because it's due north. Right? So we don't really get any marks for that because we didn't have to do anything to do that. Okay, but those are our x and y vectors for the red vector. For the black vector, okay, x is the adjacent side to the 30-degree angle, so I will have the cos of 30 degrees times 16 meters. Not 60, cos of 30. And times 16 meters. All right, so we're looking at 13.856, but obviously we'll keep all the decimals. Meters, and that will be west. 1 mark for that. Okay, calculating y is the opposite side. Sine of 30 times 16 is 8.0 meters south. 1 mark for that. Now we need to calculate, okay, our resultants x and y. So green x and green y. So green x is easy because there's only one vector where we actually go east or west, and we know that it's 13.856 meters west because that didn't require any calculating. I don't think I'm giving a mark for that. Okay, for the y component, we go north and then we come back south, right? But it's an easy calculation. 12 minus 8. Okay, will give me that I'm still 4 meters north. That one you will get a mark for. Okay, so what do we have to do? 4 marks. Okay. Now that I have the sides of my green triangle, I need to calculate the magnitude of my displacement using Pythagorean theorem. All right, so that'll be 13.856 squared plus 4 squared. Give them a mark for that. All right, so we're looking at a resultant that is 14.422 meters in length. Okay, and then we need to find theta. Okay, so for me, that's going to be 10 to the minus 1 of y over x. So that'll be 10 to the minus 1 of 4 over 13.856. Okay, so we're getting 16 degrees here. 16.1 degrees. Okay, and for me, that's going to be north of west. All right, so they can have a mark for that calculation. That puts us up to 7?
6.
Only up to 6. Okay, that's the 7th mark. Sorry, give them a mark for the X one. That's a super easy mark. Give them a mark for that. Okay, now my final answer is my 8th and final mark. So the overall displacement to 2 significant figures is going to be 14 meters at 16 degrees north of west, or at 74 degrees west of north, whichever way they drew the triangle, okay? As long as the angle matches the direction. All right, that's the 8th and final mark there. All right, so it's out of 15. Okay, give them a mark out of 15 at the top, please. Let them see it, and then I want them in a nice neat pile right here.
You had that right. You had the answer. All this work.